proposed transportation system for Metro Manila. Introduction. Metro Manila seems to be in perpetual state of traffic congestion, whether it be users of road-based or rail-based modes of transportation. Everyone can be a witness to the dreadful days of traveling within the metro. Former Department of Transportation and Communications Secretary Joseph Emilio Abaya, for instance, reported in February 2014 that the Manila Metro Rail Transit System Line 3 (MRT3) was designed to carry 360,000 to 380,000 passengers per day, but actual passenger ridership reached 560,000, according to the Fiesta 2014. This means that MRT3 has been operating at 1.47% to 1.56% of its actual capacity. Meanwhile, Waze 2016, the company known for its mobile navigation application, listed Manila as having one of the most worst traffic situations in the world based on the driver satisfaction index. Transportation problems in Metro Manila. According to CAL 2019, the crisis and transport problems that grips Metro Manila can be traced to 5 significant factors related to rapid urbanization and the slow development of public transportation in the country. These related factors that affects the transportation in Metro Manila can be break down into the following. 1. Rapid urbanization. According to CAL 2019, Metro Manila is the center of urbanization. In fact, in 2015, it can be noted that the growth of urbanization in the country has reached 70% from 30% in the 1950s. Monocentric urban form. According to the state-of-the-art of Philippine urban transportation, most of the business districts are concentrated and located in Metro Manila, which pave way for high demand of transportation within the Metro Manila. In addition, a monocentric urban center is the catalyst of traffic congestion in Metro Manila, which results high density of people, vehicles, business, and commerce. Limited mass transit network. It is also noted by CAL 2019 that the mass transit system of Metro Manila, which is in the form of the light rail transit, comprised of 52 kilometers of rail that could move an estimated 948,000 passengers daily as of 2010. On the other hand, Seoul was able to expand its train system to 287 kilometers, which can move up to 5.6 million passengers daily. Furthermore, it can be traced that Metro Manila has a 52-kilometer train system in 26 years, while Seoul has built 287 kilometers in 36 years, which is 5 times greater than the rail in Metro Manila. Low ratio of road length to motorization. The roads-to-vehicle ratio of Metro Manila is very low, wherein the roads within Metro Manila are not enough to occupy the vehicles. In addition, CAL 2019 noted that the government does not have the capability at this point to fill in the widening gap between supply of transportation system and the growing commuter demand from rapid urbanization. Proposed solutions for traffic crisis and transport problem in Metro Manila. In addressing the transportation problems in Metro Manila, we thought that we need to combine different transportation principles and concepts into single transportation system, since we cannot hinder the fact that the transportation problems in Metro Manila cannot be solved by just single idea regarding transportation system. In line with this, we plan to merge and apply the following ideas into our proposed transportation system for Metro Manila. 1 is bus rapid transit, and 2 is Copenhagen's finger plan. We plan to combine these two transportation ideas into our proposed transportation system, wherein we will take and innovate it in order to adapt and be applied to the current situation in Metro Manila with regards to transportation. By means of this, we will be able to apply the ASIM model or avoid, shift, and innovate model together with the latest technology in transportation planning of the proposed system. First, the proposed transportation system will be comprised of mainly roads instead of rails, which will stretch out throughout the Metro Manila that will be able to reach the people who use public transportation. In line with this, we cannot hinder the fact that rapid urbanization is very evident in Metro Manila. With this, public demand for transportation will greatly increase, which will lead to high population density and traffic congestion. With this, we thought that the finger plan can cope up with the rapid urbanization in Metro Manila. Second, the proposed transportation system will be able to move people from monocentric urban center, which is very efficient and helpful in monocentric urban form. Since most of the business districts are in Metro Manila, many people or workers are traveling from time to time. With this, the proposed transportation system can be valuable to the people or workers in Metro Manila, since it promotes transit-oriented development which integrate different places to bring people, activities, buildings, and public space together, supported by easier access through walking, cycling, connection between the developments and transit stations. With regards to this, there will be connection between the people and the transportation. The people will be able to use public transportation and use their time exploring the greener locations during the travels from different locations in Metro Manila. Because we want to have because we want the Metro Manila to be a place to live and work. Lastly, limited mass transit network will be emphasized through the proposed transportation system and will be able to address properly since this system mainly comprised of roadways for buses. By applying this transportation system, we can create road networks which represent the fingers that will be able to extend to farther locations in Metro Manila that do not have access to public transportation. In addition, the proposed transportation system will be able to determine that urban development should generally take place in core urban regions and peripheral urban regions, the palm of the hand and the city fingers.
Bus Rapid Transit System. It is defined by Levinson et al. As a system composed of facilities, services, and amenities that work together with the goal of improving the speed, reliability, and bus transit. It is considered to be fast and reliable. It is also expected to be passenger-friendly since it utilizes technology in showing the passengers necessary information regarding their trips. The next is energy consumption. According to Vincent and Jeram, Bus Rapid Transit or BRT has less carbon dioxide emission per passenger mile when compared to other public transportation such as LRT. This gives Bus Rapid Transit a great potential in greenhouse gas reduction, which is beneficial to the environment. The next is electric bus operation. Battery-powered electric bus is considered to be efficient in terms of its impact to the environment. It also opens up new challenges on how BRTs can be optimized in different situations. Next is global implementation. According to Ardila, think tanks is a major contributor in making BRT policies and promoting them internationally. think tanks acts as the promoter and developer of policies regarding BRT that made it successful internationally.
Related literature about Copenhagen's Finger Plan. Actual spatial development. The combined impact of land use and transport infrastructure development has therefore not contributed to bringing Copenhagen metropolitan area closer to the goal of sustainable mobility. On the positive side, Copenhagen's excellent and continually improving network of bike paths must be emphasized. The new metro has also contributed positively, although its ability to shift travelers from car to public transport may be limited compared to the size of investments. Investigated land use and transport infrastructure plans. Issues of sustainability are not seen to be conflicting with such priorities, but could rather aid the green branding that Scandinavian and Nordic countries already benefit from. An obvious consequence of this is that sustainability is subordinated to other goals, and the planner's role thus becomes that of best implementing sustainable solutions that will allow growth to continue. Sustainable mobility. Transport authorities and planners involved in transport infrastructures development in the Copenhagen region have generally considered road development as a measure to combat congestion. During most of the investigated period, road pricing was not on the political agenda, but during the recent years, the municipality of Copenhagen has cooperated with 9 neighboring municipalities to put pressure on the national government to allow this measure to be implemented.
Interpretation of data. Different factors were considered for the proposed transportation system. First, circumferential and radial road volume in Metro Manila. It can be drawn from the data gathered from Metropolitan Manila Annual Average Daily Traffic AADT 2018 that private cars dominate the roads in Metro Manila, wherein the road capacities cannot withstand the number of vehicles in Metro Manila. In line with this, the data shows that Metro Manila is vehicle or car dependent. There's more vehicle on the roads, which is the main catalyst of traffic congestion in Metro Manila, which has a total number of 2,811,455. If we try to scrutinize the daily volume of vehicles in circumferential and radial roads in Metro Manila, considering the different types of vehicles, specifically car, PUJ, UV, TXI, PUB, truck, trailer, MC, and tricycle, C1 Recto has the lowest number of daily traffic, which is 66,814 in terms of circumferential roads. On the other hand, R8 A Bonifacio has the lowest number of daily traffic, which is 64,076 in terms of radial roads. Also, the circumferential road that has the highest daily traffic is C4 or EDSA, which has 383,828. The radial roads that has the highest number of daily traffic, on the other hand, which has 449,520, is the R7 Avenue and Commonwealth Avenue. Population per city in Metro Manila. It can be seen in the data in the figure provided that Metro Manila has a total number of populations, which is 12,877,253 as of August 1, 2015. As we look into the trend of the population from the year 1990 to 2015, it grows continuously, which explains how crowded Metro Manila is. as the time passes by. This explains that Metro Manila will continue to experience traffic congestion since population growth are inevitable, which is the main catalyst of the increase in vehicles on roads. The city with highest number of populations on 2015 is the Quezon City, which has 2,936,116, followed by Manila with 1,780,148. Alternatively, the city with lowest number of populations is Navotas, which has 249,463. The number of populations per city is represented by the red circles with different sizes. The larger the circle, the higher the number of population and vice versa. Population density. The figure shows how dense a specific city in Metro Manila. As the color turns to become violet, means higher population density. And as the color becomes closer to red, population density lowers. The population density of Metro Manila is very high, especially Manila, wherein it is the world's most densely populated city with 42,425 per square kilometer. This is all contained within a small area. The city with lowest population density in Metro Manila is Muntinlupa, with 12,880 people per square kilometer. Having high population density creates more travel demand in a specific place, specifically in Manila, which number of motorized vehicles. The graph shows the increase of motor vehicle in each country, like in China. It can be seen in the graph that in the year 2050, the rise and growth of the motor vehicles, especially in Asia, is constantly growing without any bounds. It can be extracted from this that there is a need of mass transit that can move people or commuters into their destinations safely and efficiently. As I said in the introduction, MRT and LRT accommodates too much commuters that is beyond to its design capacity. Through this data, we can see that there is a need in mass transportation system, especially in Metro Manila. Moreover, several cities across the world are using a BRT system. These include Bogota, London, Sydney, Istanbul, and Taipei. By far, however, the greatest success story in BRT comes from Curitiba, Brazil, wherein it can be extracted from the graph that Brazil is not fully reliant in the vehicles, specifically cars and motorcycles like Philippines, Vietnam, and China. Through integrating the BRT into the Copenhagen's finger plan, we can disrupt the traffic congestion in Metro Manila gradually, wherein we can reduce the number of commuters using the LRT and MRT so that it can accommodate according to its capacity, and will be able to provide efficient and comfortable travel experience to the commuters. Through our proposed transportation system, car dependency, which produces air pollution, social exclusion, fossil fuel dependence, and neighborhood disruption will be minimized gradually. Since we applied the principle of the Copenhagen's finger plan in our proposed transportation system together with BRT, we analyzed the data wherein rapid growth of urbanization occurs through the use of varying factors. In line with this, we placed the Manila in the palm of our finger plan, since it has the highest population density, which creates high travel demands. It will be linked towards the other destinations through the use of bus rapid transit. Furthermore, the combined analysis of the data that we have is the backbone of the proposed transportation system, wherein we want to create lanes or routes in specific radial and circumferential roads in the Metro Manila for bus rapid transit that can move people to different locations in faster and efficient ways, that can reduce car dependency in the Metro Manila, wherein it can divert commuters' choices in terms of public transportation and mass transportation. With regards to this, traffic congestion on the roads can be reduced and rail network will be able to accommodate the number of commuters within its capacity. Since commuters can use BRT, since it has a principle, think rail, use buses. Lastly, transit-oriented development will be applied in each terminal, wherein the transportation system will be interconnected to one another and to the other commuters as well, wherein commuters will be able to experience comfortable, efficient, and faster public transportation. Methodology and design. We plan to integrate the Bus Rapid Transit or BRT into the finger plan, wherein we will use buses instead of trains and railways, since BRT is thinking rail, use buses. Regarding to this, we will be using the idea of the finger plan in creating the dedicated routes for our buses, and we will be applying the principle of bus rapid transit as a mass transit instead of rail transit that will be able to move people in Metro Manila. By applying the idea of the finger plan, we plan to create different dedicated routes for the buses which will be placed along the fingers of the plan. The locations or areas with highest population density and travel demand will be placed inside the palm of the finger plan. In creating the dedicated main routes for the buses, we will determine and try to predict the possible areas in Metro Manila that will have rapid growth of urbanization and travel demand in the future using the 4-step model, which will be placed in the fingers so that the transportation system will be able to move the people in the specified areas into other locations in Metro Manila. In addition, we will designate the most suitable location of the regions that will be inside the palm of the transportation system, wherein it will be the main link that will connect the 5 fingers. The regions that will be placed in the palm will have designated stations that will represent transit-oriented development. Also, this proposed transportation system will give the people a lot of mobility.
The transport planning process aims to estimate the future travel demand on the transportation system. This quantification of travel demand can be done using the conventional 4-step model of travel demand analysis or forecasting, which includes trip generation, trip distribution, modal split, and traffic assignment. But before travel demand forecasting is employed, we must collect the needed data, and hence a traffic survey must be carried out. Here are some of the necessary traffic surveys conducted by transport planners. First, household interview surveys, which aims to acquire information about the socio-economic conditions and travel characteristics of households within the study area. Second, cordon line survey, which is used to gather data about the non-residents of the study area, which would give information on the external trip data. And lastly, screen line survey is used mainly for the calibration of data and would be compared to the HIS results. While the traffic surveys are being conducted, the transportation database should be designed and built. The transportation database should include highway network, transit network, and socioeconomic data encompassing the study area. The highway network tells the level of surveys of roads, streets, and the highways. Transit network establishes routes. On the other hand, the data extracted from household interview surveys can be used for the socioeconomic part of the transportation database. Once the transportation database has been finalized and the traffic surveys has been employed, the future travel demand can now be quantified using the 4-step model. Step 1. Trip generation. Trip generation refers to the number of trips per analysis area. It basically addresses the question, How many trips will begin or end in each traffic analysis zone? Trip generation has two aspects. First, the trip production or the trips associated with the outbound direction, and second, the trip attraction or the trip ends associated with the inbound direction, like workplaces and schools. Additionally, certain considerations have to be studied in trip generation before it is employed. The amount of urban activity, such as the number of employees and households per zone, and the character of urban activity described through socioeconomic variables such as family size, family income, and car availability. Step 2. Trip distribution. Trip distribution provides the linkage between trips produced and trips attracted for each zonal pair. Trip distribution answers the question, how many trips that begin at a given origin will end at a given destination? The outputs of trip generation and the travel impedance obtained from the transportation network are the inputs of trip distribution. The output of this step is mainly an origin-destination matrix that tallies the number of trips between each pair of zones. Results of trip distribution are assigned to the transportation facility to determine the travel demand, which would then relate to the carrying capacity of that facility. Step 3. Modal split. Modal split refers to the determination of the mode of transport to be used by travelers. Modal split gives the answer to the question, how many travelers will choose each mode of transportation? Before analyzing the differences in mode choice, it is important to understand the factors that affect how people make choices when traveling, such as the characteristics of the trip maker, characteristics of the trip, and the characteristic of the transportation system. Step 4. Traffic assignment. Traffic assignment is the last step in travel demand forecasting. This process determines the routes or paths that will be taken by trip makers to travel from an origin to a destination. It will answer the question, what route or path will be taken by each trip maker? The assignment of trips to the highway and transit network is the output of this step.
High capacity and high quality transportation system. The integration of bus rapid transit in the finger plan is innovative transportation system which has high capacity and high quality service that mimic urban rail at a much lower cost. The proposed transportation system will promote public transportation which is efficient, faster, and reliable, since the proposed transportation system manifests the following. Exclusive lanes, which creates physical separation. Advanced bus technology, which means clean fuels, lightweight materials, low floors, advanced communications, and docking systems. Supportive elements, which means signal priorities, bus turnouts, GPS, automated routing and dispatching. Expeditious fare collection and boarding, which means it can be off vehicle payment, smart cards, or NFC. Line priority. In addition, the design will have lane priority wherein giving buses priority to lanes. Vehicle design. Low-level boarding, faster boarding time for all passengers, namely those in wheelchairs, which means shorter dwelling time at the bus stop. User-friendly. Providing proper information to the customer is crucial for high-quality transit information. Therefore, to increase the appeal of a BRT system and consequently ridership, each stop should have the following. 1. A stop name. 2. Route names and destinations for all routes serving the stop. 3. Span of service and frequency of service. 4. service schedule for low-frequency routes, and 5. A system map. We will be integrating and innovating the idea of bus rapid transit in the finger plan, wherein we plan to create 5 different types of buses such as public buses, premium buses, city buses, shuttle buses to attraction, and shuttle buses to hospitals. Since we plan to create 5 different types of buses, there will be different routes for each type of bus. The planned routes will be the following: main routes for public and premium buses, city routes for city buses, attraction routes for shuttle buses to attraction, and hospital routes for shuttle buses to hospitals. The plan: main routes for public and premium buses. The figure shows the 5 main routes of our proposed transportation system, wherein it will be used for the public and premium buses. These 5 main routes represent the 5 fingers of our plan, wherein population growth and demand for transportation are very evident. It can be seen that all the main routes intersect in Manila City, which has the second highest number of populations in Metro Manila. It is located at the palm of the finger plan. First main route will traverse Manila, Valenzuela, and Navotas. Second main route will traverse Manila, Quezon City, and Caloocan. Third main route will traverse Manila, San Juan, Mandaluyong, and Pasig. Fourth main route will traverse Manila, Makati, and Taguig. And lastly, fifth main route will traverse Manila, Pasay, Parañaque, Las Piñas, and Muntinlupa. Since our proposed transportation system will integrate the bus rapid transit, we critically studied the radial and circumferential roads of Metro Manila, wherein some spaces or lanes of it will be used as exclusive routes for the different buses of our proposed transportation system. First main route, which is in color red, will traverse the 9th Radial Road or R9. Second main route, which is in color blue, will traverse the 7th Radial Road or R7. Third main route, which is in color violet, will traverse the 5th Radial Road or R5. Fourth main route, which is in color yellow, will traverse the 3rd Radial Road or R3. Fifth main route, which is in color orange, will traverse the 2nd Radial Road or R2. Dedicated lanes will be placed in these specific radial roads, wherein this will be used for public and premium buses. There will be 5 intersection points in First Circumferential Road or C1, represented by light circle with light blue color, which will be the terminal stations in Manila City. The 5 intersection points along C1 will be in the specific locations within Manila City. Since C1 has the lowest number of total daily traffic, which is 68,814, since it was placed inside the palm or in Manila City, wherein commuters can easily access the buses in different terminals. City routes for city buses will traverse in 5th Circumferential Road or C5 in color black. There will be dedicated lanes that will be placed in the C5 for the city buses, since C5 has the longest road length which can travel to different cities. Attraction routes or shuttle buses to attraction will traverse in the 1st and 2nd Circumferential Road or C1 and C2, which is color green and pink respectively. These circumferential roads are the qualified routes for attractions, since these roads are not very congested like other circumferential roads like C4 and C5. Hospital routes for shuttle buses to hospitals is traversed in the 3rd Circumferential Road or C3, which is represented by the color sky blue. There will be dedicated lanes in C3 for shuttle buses or vehicles to the hospitals, since it has the second lowest number of daily traffic, which is 81,219, which is suited for the emergency cases and intersects into the 5 main routes and traverse the different areas in Metro Manila. Through this hospital routes, traffic congestions will not be a hindrance in case of emergencies, and the medical professionals may be able to respond quickly to different locations through this route since it is connected to 5 main routes and different locations as well. In addition, we plan to create main terminal station represented by ellipse with the dark blue color in Quezon City, which has the highest number of populations in Metro Manila. Moreover, smaller bus stops will be placed in each city except in Manila City and Quezon City, which are represented by circle with green color. Moreover, our proposed transportation system is more than mobility investments for relieving traffic congestion in Metro Manila. Hence, it also exploits transit city shaping opportunities through integrating BRT in finger plan, wherein it will be an integral upfront part of the system planning, not an afterthought. What technology will be applied in our proposed transportation system? Latest technology will be applied to the proposed transportation system. We will also integrate the near-field communication or NFC technology and RippleNet technology to make the transportation process and payments between buses faster and efficient using beep cards, NFC-enabled phones, and cards, and the like. RippleNet technology for payment processing. RippleNet technology will be integrated in the payment system wherein it will be the main core in terms of payment processing since it is the world's most accessible global payments network that runs in the blockchain. First is everywhere. Expand your reach by offering more places and ways to move money. Second is reliable. Build trust by increasing visibility and eliminating payment failure. Third is instant. Provide instant payments so money or payment arrives when customers need it. Low cost. Capitalize on operational and cost efficiencies to further grow business and transportation system. Hassle-free payments can be provided using NFC-enabled smartphones, beep card, payment cards, mobile wallets such as PayMaya, CoinsPH, GCash, and others. In addition, there will be dedicated time for each bus to arrive in each terminals and stations, which can be monitored in the mobile application that will be created. In line with this, the commuters can track the location of the buses and their location too using the GPS technology.